Welcome to the DIY Honda Garage channel. In this presentation, we will discuss the DTCs P0351, P0352, P0353, and P0354, which indicate ignition coil circuit malfunctions for the number 1, number 2, number 3, and number 4 cylinders, respectively, in the Honda Civic models from 2016 to 2021. Each of these diagnostic trouble codes, DTCs, points to potential issues in the ignition coil circuits. An ignition coil plays a crucial role in the ignition system. It transforms battery voltage into high voltage to ignite the air-fuel mixture in the engine cylinders. If there's a malfunction in any of these circuits, it may lead to misfires, reduced engine performance, or increased emissions. Understanding these DTCs is essential for effective troubleshooting and ensuring the engine runs smoothly. Attention to DTCs is vital, as they guide technicians in diagnosing and rectifying issues efficiently. DTCs P0351 through P0354 indicate a malfunction in the ignition coil circuits of individual cylinders in the Honda Civic. The number 1 cylinder corresponds to DTC P0351, followed by number 2 with P0352, number 3 with P0353, and number 4 with P0354. Ignition coils are essential components that transform a low 12-volt battery supply into a high-voltage output required to ignite the fuel-air mixture in a cylinder. Each coil is located directly above its corresponding cylinder and is connected to the engine control module or powertrain control module, PCM, via wiring. If any coil circuit fails, it can lead to ignition issues, causing poor engine performance and increased emissions. Therefore, accurate diagnosis and prompt repair are crucial for maintaining engine functionality and longevity. Several factors can lead to the ignition coil circuit malfunctions reflected in DTCs P0351 to P0354. A primary cause is a faulty ignition coil. If the coil cannot generate sufficient voltage, the engine will misfire or fail to start. Secondly, open wire connections can disrupt the electrical flow between the ignition coil and the PCM, leading to these DTCs. Additionally, shorted wire connections can create unintended paths for current, potentially damaging components. Lastly, a faulty relay circuit board may fail to supply voltage to the ignition coils, resulting in greater ignition issues. Understanding these potential causes is critical for effective troubleshooting and ensuring the vehicle's ignition system operates properly. When experiencing DTCs P0351 to P0354, you may observe several symptoms that indicate a malfunctioning ignition coil circuit. The most prominent symptom is engine misfire, which occurs when the fuel-air mixture fails to ignite correctly, resulting in rough engine operation or stalling. Additionally, you may notice a reduced engine power, as the performance diminishes when one or more cylinders fail to operate effectively. The check engine light will likely illuminate on the dashboard, indicating a fault in the ignition system that requires immediate attention. Lastly, increased emissions could occur as unburned fuel exits through the exhaust system, contributing to air pollution. It's essential to recognize these symptoms to prompt timely diagnosis and repair. The first step in troubleshooting DTC P0351 to P0354 is to verify the problem by following specific procedures. Begin by turning the vehicle to the on mode, which powers the electrical systems without starting the engine. Next, clear any existing diagnostic trouble codes using the Honda Diagnostic System, HDS. This step ensures that you're working with the most accurate data for diagnosing the issue. After clearing the DTCs, start the engine to check for any pending or confirmed DTCs that may reappear. If P0351 P0352, P0353, or P0354 appears again, it indicates that the malfunction is persistent and you should proceed to the next troubleshooting step. If no DTCs are present, it may signify an intermittent fault, warranting checks for loose connections or poor wiring. In step 2 of the troubleshooting process, you will need to check the ignition coil related to the problem cylinder. Start by turning the vehicle to the off-lock mode to safely manipulate the ignition components. The next step involves exchanging the ignition coil from the malfunctioning cylinder with one from an operational cylinder. This swap helps to determine whether the issue resides in the ignition coil itself. After making the exchange, start the engine again to see if any pending or confirmed DTCs arise with the HDS. If the DTC reappears at the exchanged position, it confirms that the original ignition coil is faulty and needs replacement. If the DTC does not reappear, you will need to move on to the next troubleshooting step to investigate further. Step 3 involves checking for a shorted wire in the ignition coil relay circuit. Begin by turning the vehicle to the off-lock mode to ensure safety while performing checks. The first item to examine is the A15 fuse, which is a 15-amp fuse located in the underhood fuse relay box. If the fuse is blown, this indicates a potential short circuit that requires immediate attention. If the fuse is intact, proceed to inspect the IG coil RLY out, IG1, IGN. Wire for any shorts between the relay circuit board and the ignition coil, as well as the +B IG coil wire between the A15 fuse and the relay circuit board. Finding any issues necessitates repair actions, including replacing the blown fuse if applicable. This initial physical inspection can reveal significant electrical problems affecting the ignition coils. In this fourth step of the troubleshooting process, you will evaluate the relay circuit board responsible for supplying power to the ignition coils. Start by removing the relay circuit board, ensuring that you handle it carefully to avoid damage to connectors or pins. Next, conduct tests on the relay circuit board to determine its functionality. If the board is found to be operational, you can proceed to the next step. However, if it is deemed faulty, it must be replaced to resolve any issues causing ignition coil circuit malfunctions. The relay circuit board acts as a crucial link in distributing electrical signals. If it fails, the entire ignition system can be compromised. Correctly diagnosing this component ensures an effective resolution to the ignition issues. Step 5 involves verifying the wiring integrity within the ignition coil relay output line. After reinstalling the relay circuit board, disconnect the 3P connector of the problematic ignition coil. This disconnection allows you to measure the voltage at the test points, ensuring accurate readings. With the vehicle in the on mode, you will measure the voltage between the designated test points, the ignition coil 3P connector number 1 and body ground. If you find battery voltage during this test, it confirms that the wiring to the ignition coil is intact, and you should proceed to the next troubleshooting step. However, if there is no battery voltage present, it indicates an open in the IG coil RLY out, IG1 wire, necessitating immediate repair action. Correct voltage measurements are crucial to diagnosing wiring issues accurately. In this sixth troubleshooting step, you will check for the continuity of the PG coil line. First, ensure that the vehicle is in the off-lock mode. Conduct a continuity test by checking between the appropriate ignition coil 3P connector terminal number 2 and body ground. If continuity exists, it indicates that the PG coil wire is functioning correctly, and you can progress to the next step. However, if there is no continuity, this signifies a possible open in the PG coil, wire between the ignition coil and ground point G101. In such a case, repairs will be necessary to restore the proper connection. This step is essential for identifying faults in the signal paths that control the ignition coils. Step 7 requires checking for shorts in the ignition lines to ensure everything is functioning correctly. Start by jumping the SCS line using the HDS and allow the system to settle for over a minute. Afterward, disconnect the PCM connector E, which controls various engine functions, including the ignition. You will then check for continuity between body ground and the specified PCM connector terminals, depending on the problematic cylinder, e.g. number 1. 1 corresponds to terminal number 37. If continuity is found, it suggests that the wiring is intact and that you must take further steps. Should there be no continuity detected, there is a short in the ignition wire between the PCM and the ignition coil that must be addressed promptly. This step focuses on ensuring the integrity of electrical connections in the ignition system. In this final step of the troubleshooting process, your focus shifts to checking the continuity of the ignition coil lines. Start by verifying continuity between the appropriate ignition coil 3P connector terminal number 3 and the corresponding terminal on the PCM connector, ensuring that power can flow correctly. If continuity is detected, this indicates that the IGN wires are in good condition, and you may need to consult authorized service information or consider substituting a known good PCM if issues persist. Conversely, if there is no continuity, it reveals an open in the IGN wire between the PCM and the ignition coil. This will require repairs to ensure all electrical signaling paths are functional. Following this comprehensive process refines your approach to diagnosing ignition issues. After completing the repair steps for DTCs P0351 to P0354, it's vital to conduct a final verification to confirm the effectiveness of the repairs. Begin by clearing the diagnostic trouble codes once more using the HDS to ensure a clean slate for testing. Following this, take the vehicle for a test drive under various conditions to simulate real-world operating scenarios. It's critical to monitor engine performance for any signs of ignition malfunction or the reappearance of DTCs. If the test drive confirms that the ignition system operates smoothly without any related faults appearing, you can verify that the issues have been successfully addressed. This final verification solidifies the integrity of the ignition circuit and ensures long-lasting engine performance. Preventive maintenance plays a crucial role in ensuring the long-term health of the ignition system in your Honda Civic. Regular checks on the ignition system components, including ignition coils, can identify potential problems before they escalate. Regularly inspect wiring and connectors to catch any signs of wear, corrosion, or loose connections that may develop over time. Using quality OEM or high-grade replacement parts when performing repairs enhances the durability and reliability of the system. Additionally, keeping up with routine vehicle maintenance according to the manufacturer's recommendations can prevent issues that might trigger DTCs such as P0351 to P0354. Implementing these preventive measures helps preserve vehicle performance and minimizes future repair costs. In summary, understanding the functions and implications of DTCs P0351, P0352, P0353, and P0354 is essential for effective vehicle maintenance and repairs. These codes relate specifically to ignition coil circuit malfunctions that can significantly impact engine performance. Following a systematic approach to troubleshoot these DTCs facilitates accurate diagnosis and repairs, ensuring that problematic components are correctly identified and resolved. Regular maintenance, including ignition system inspections and quality part replacements, plays a pivotal role in preventing future issues that could trigger these codes. By adhering to these best practices, you can ensure that your Honda Civic remains reliable and efficient on the road. Please like and subscribe to the channel. See you next time.